This car isn't real, and neither are many of the things I see in movies. You probably know a lot of these effects are created using a technique called CGI. But what does that mean? How do you go from a mathematical representation of an object to a photorealistic image that blends perfectly with the original scene? This is accomplished using a method called ray tracing. Ray tracing simulates the way in which light interacts with objects to produce an image.
A ray tracer takes the objects, lights, and camera that make up a virtual scene as input and gives an image from the perspective of the camera as output.
When you hear ray tracing, this actually refers to path tracing, which casts rays out of the virtual camera and traces them until they reach the virtual lights. So, here's how it works. First, rays are cast out of the camera's pixels until they intersect with objects. Then, they bounce off the objects. If the object is shiny, the ray bounces off based on the angle at which it hit.
Specifically, it'll bounce off at the same angle, but reflected along the normal, which is a vector perpendicular to a given object's surface.
If the object is matte, the rays just bounce off in random directions. Of course, most materials are more complex than this, so more advanced models are usually used.
Ray tracers have a limit to the number of bounces a ray can have, otherwise tracing them could potentially take forever.
Once the rays have been traced, the pixel colors can be calculated. For each ray, you check if the ray hit something. If it didn't, then the pixel is set to a background color, usually the color of the sky from an environment map. If the ray got to the maximum number of bounces without ever reaching a light source, that ray contributes no color. If it did hit something, then you check if that ray eventually reaches a light source. If it reaches a light source, then that light, the ray, and everything it hit is input into a lighting model which decides the color of the pixel. Lighting models can vary from very simple to very complicated. A common one is called a bidirectional reflectance distribution function, or BRDF, and it allows for advanced effects like specular highlights.
Others can produce subsurface scattering, which is used for skin and cloth materials, refraction, which is used for glass and water materials, and volumetrics, which is used for fog, smoke, and fire materials.
The most basic lighting model simply follows along a ray from the light source to the camera, and for each bounce, multiplies the previous color by the current object's color. This will yield an image, but disallows stuff like specular highlights. This is all assuming that you're casting one ray per pixel though. Normally, hundreds or even thousands of rays are cast out of every pixel, and their calculated color values are averaged to get the final color of the pixel. Finally, this image can be combined with the original footage through a method called compositing. And that's how ray tracing works, on a basic level. If you want to learn more, there are some links down in the description. Thank you for watching my entry into the Breakthrough Junior Challenge.